Okay, so the title on the paper might read Determinant of a 3x3 matrix, which would be a next step you could take if you're studying matrices or linear algebra, equations of lines and their intersections, etc. But we are going to use it to calculate something in vector math called the cross product. The cross product. I want you to see the word product here. Sometimes is a word that refers to a type of multiplication. So we have scalar multiplication already. Change the scale or the magnitude of a vector. We have the dot product, and the dot product by itself doesn't seem to mean as much, but it's used in a couple of significant formulas, the cosine of the theta between vectors and the projection of one vector onto another. So this is called the cross product. So the purpose of this little segment is to just show you how to calculate a cross product. The bits and pieces that follow will give us some of the starting uses for it. So let's suppose that we have two vectors. And I chose to use the IJK notation. Please note the hats in my room are optional. This little symbol notation on top. But for some instructors, that's not optional. And some use other notation. I tend to mix up my vector notations. So we've got two vectors, a vector u, which has three components, and a vector v, which has three components. So we're playing with the three-dimensional world here. The reason has not been made clear yet, but it turns out you will need 3 dimensions for a cross product. Then one definition of the cross product of two vectors, and this is called the cross in your cross product here. All right, this is called this is the cross product notation. So this definition would be, it's the determinant of a particular matrix. And the matrix in question is this matrix right here. So this matrix has 3 rows and 3 columns. It has the symbols I, j, and k from a 3-component vector. And it has the individual components of the first vector in this middle row and the second vector in this last row. And that order is significant. So this is the first vector, its components are here. And this is the second vector, its components are there. Okay. So the method I'm going to show you to calculate this determinant of a 3x3 has a name. When I was taking my first linear algebra course ever, it was called expansion by minors. But the name is not something I put on a vector calculus exam, but it might be something the linear algebra professor holds you accountable for. But let's just look at the words in English. Expansion means to make it bigger, break it into pieces. And minors, think of a smaller or lesser piece. So we're going to break it into smaller pieces. Sort of like mom telling you to cut your food into smaller bites and don't make a pig of yourself. My mom would never have said that to me, of course. So here's how you expand a 3x3 matrix into minors. But you should first note that there are other methods available, and I don't hold my students accountable to the method I'm about to show. However, I'm going to pretty much use this method whenever I calculate a cross product. And that calculation goes into the last chapter of our vector calculus course. So it's going to be used on and off quite a bit. So here's how you look at it. The determinant of a 3 by 3 matrix involves you breaking down this matrix into 3 pieces. The first piece will be multiplied by the I, and the second piece will be multiplied by the J, and the third piece will be multiplied by the K. Again, hats are optional. And to find the minor that goes with the I, what you do is you cross out the column and the row that has the I in it. And that little 2 by 2 matrix is the matrix associated with the I. That little 2 by 2 matrix is the one associated with the I. And so U2, U3, V2, V3. We're going to calculate the tiny little 2 by 2 determinant of that. And I'm going to go ahead and write that. So this diagonal, if you recall, for a 2 by 2 matrix, U2, V3 minus this diagonal, U3, V2 multiplied by the I component. To find the minor that goes with J, you cross off the column and the row that has the J in it, and that little set of 4 values, U1, U3, V1, V3, that's it. That's the one that goes with J. U1, U3, V1, V3. And if you recall from the 2 by 2 problem that we had done, when you are dealing with the Y or the middle component, it was the opposite symbol, that little calculation. It wasn't a formal proof, it was just an observation in our numerical example. Minus U1, V3 minus U3, V1 J. More piece. The K component, if you haven't figured it out, we're going to cross off the column and cross off the row that has the K in it. And there's your 4 numbers. You might recognize those numbers. U1, U2, V1, V2. And again, I won't go into the proof of this, but this last minor term will be added. So we have an addition, a subtraction, and addition here. Again, I'm going to save that for the linear algebra instructor. So plus first diagonal, U1, V3, noops, typo, that's a 2, U1, V2 minus second diagonal, U2, V1 times K. Now, technically, this is our formula. This last row here. In our particular textbook, they distribute the minus sign and they call this a plus sign, and they rewrite the order of this. That's not a problem. And there's methods different from what I've shown you here, and you're welcome to do a little homework on this calculation. To me, this is my picture, and this is how I break it down into pieces and organize it. And this is probably the single most unusual fact to memorize to keep it going. So you would call this, I guess, a formula. But I would call my formula more of a recipe, and I build it from scratch every time. And I can do the arithmetic rather quickly, but in the case when you don't see actual number values, This just looks kind of messy. It's not very clean looking. Now, I don't mind if you learn this technique. I don't mind if you just memorize the formula. I don't mind if you search for another method that would work. Find one, get proficient with it. You can use any of those on any of my assessments, quizzes or exams, doesn't matter to me, homework or otherwise. What I haven't done for you is answer this question: what does cross product do? You're going to have to come and watch the next episode or cheat and ask your smartphone to do it for you. Until next time.